So today I will show a full process of how to measure the particle size and the zeta potential using the NTA machine. So first we have to turn the computer. It's already on and the password is 126. And then we have to turn the machine. And we have an indicator light here. And the button is behind the machine. So now the light is on. And then the next step is turn the software, the Zetaview software. Double click. And then wait for the software to operate. And follow the steps. So first, please make sure the fluorescence filter is removed. And here we have already put the fluorescence meter. So the normal position is already removed. If you want to use the fluorescence meter to check the fluorescence of the particle, you have to You have to put up the filter. So now the original process is already removed. So you don't have to change the position of this filter. And then press OK. Now it's the initialized process. So we have to be careful. The two indicators here should be green. The first one is the cell is connected. The second one is the cell quality should be very good in green. The color bar is green. And now here, after the first process is check the fill level of the water reservoir. Is this one. And this one is connected with the pump 1. So you have to first click rings. Use pump 1, click rings to fill the water in the cell for the measurement. So now and then go to the waste here. And because some pollutions in the whole cleaning room, so you can see some bubbles, not the bubbles, the scattering point. It means some particles still in the distilled water. So we suggest if you want to full clean the process, you inject the clean water from here. You inject use the syringe, 5 milliliter clean water from here to clean the cell. So now this is the process. The cell has been rinsed with this distilled water, but you can still see the scattering point. It's small particles. So that's okay. It's the cell quality check program. So now next is fill the cell with 100 nanometers alignment suspensions. So this is the original 100 nanometers standard PS particles, and this is the original solution. So we just take 10 microliter diluted in 10 milliliter, the 1000 diluted solution. We prepared it as here. This is the first stock solution, diluted 1000 times. And then the final solution is you have to dilute it again by 250 times. So it's the final calibration concentration for this step. So every time you do the experiment, you take the concentration this, the 250,000 diluted PS sample. And then you use a new syringe to take the solution out. Be careful, like when you're injecting the sample inside, try to avoid any bubbles. So like first fill some liquid inside and then inject the liquid. So you can see from here the sample is already injected, and the parameter here, sensitivity is 60, and the shutter is 150, and we can do the auto alignment with these parameters. So do not logically change the parameters, this one and this one. So then we click OK. So when the whole calibration process finished by the equipment, so the manual will systematically change to the analysis manual. So you need to check the what? But it's okay. So now after the calibration process finished, the Zetaview video microscope is now ready for experiment. So every time you have to see this reminder, then you can start your experiment. If any of the click OK. So like if any of the process failed, like the auto alignment failed or the focus calibration is failed, so you have to go back, like refill the sample, or like do the cleaning process of the cell to make sure the two calibration process is completed. So here, things like how we check the quality is good for your experiment is the two indicators green, and the particle is the standard particle is look like this one, and the scale bar. The two indicators, the scattering intensity and the number of detected particles is in green. So now the equipment is you can measure the sample. So how we remove the standard particles here? First, you use the pump. You use pump to remove the solution in the cell, or you can also inject clean water from here, like at least 5 milliliter inject from here to remove the solution in the cell. So the pump will automatically stop like after 2 minutes or 3 minutes, or you can also manually stop it. Yeah. So that's because the water is not clean here. We inject some clean water. From here. Remove the bubbles. So now the screen is all black. You cannot see it's no obvious particles in the solution. Now you can inject your sample with separate concentrations. Here we use some our own sample, like the gold solution in their water, and then we use the new syringe to inject the sample. So here the sample is already injected, and when we do a demonstration of how to measure the particle size and how to measure the zeta potential separately. So first, like before we do the measurement, we go back to the cell check process, and then we want to adjust the parameters here to to make sure the intensity and the number of particles is in green. So now the scattering is too high. We move to the measurement side. It's the same. The parameter is the same. And then we click number of particles via sensitivity. This will give the equipment will give a recommendation of how the sensitivity will be set for your measurement. The concentration is too high. The data has been read. So we can sensitivities. Now we should lower the sensitivity. So this is like how many particles are observed by the screen, and now the particles. So like we mainly change the sensitivity and the shutter, the two parameters, to make sure the particles you want to measure is in the right scattering light, and these two are in green state. And now is the concentration detected by the equipment. It's the 10/7 the concentration, and because this is okay. And if necessary, we want to check if there is any drift. So we click here. So the green line means the drift is okay. We can start the measurement. After check the drift here, and then the equipment set 11 positions here. So before your experiment, you have to check you can suggest you check every position to make sure the particles is uniformly dispersed in the solution. It means some bubbles. After we injected the sample, we have to check the 11 positions to see whether the particles are uniformly dispersed. So we have 11 positions here, and then we can select 3. So now the particle dispersion looks well, and we go to the measurement. And we set the number. And then we click the number of particles via sensitivity. And this will give a recommendation of the suitable parameters of sensitivity here. And usually we take the volume, like the 200 nanometers, corresponding 75, the sensitivity. I see. And then we click run video acquisition. So make sure the autosave TXT and PDF files are selected. This is your final result. And then click run video acquisition. So here you have this type your sample name. This is the file name for PDF and TXT. And this is the code. And select the folder here. And the data is saved in the Z disk. This is not good. Select the folder. And so currently this is no SOP, so the indicator is red. And then, so if you have previously saved the SOP, you can click this one. And now the green one means you are using the previous SOP. So if no, you just here. So we are going to, if we're going to measure size, click size, and if zeta potential. So this demonstration is the size measurement. So we pick 11 positions and we do 2 cycles. This is like how often the 11 positions are measured. This is 2 cycles. And the median means like the whole video concludes 30 frames. And these post-acquisition parameters you can change after the video is captured. So it's okay. These parameters can change after. And this too is the before you take the video. And now you can see current settings as new SOP. So like this, go. And press enter, and then press OK. So now you create your own SOP here. And then after this part and this part setting well, click OK to start the size measurement. So when the size measurement finished, the software will automatically change to the analysis mode. So here. So the histogram of the size distribution will generate later. So here is the result of the 11 positions you measured. So with the cross here, it means the data is selected. So if some drift or some bubbles in your cell, then the cross is removed, and the reason removed will be listed here. So besides so this is the software recommended data you can collect. You can also manually remove some data you don't need. So here we just accept all the data, then we press continue. Then this PDF is also automatically formed. This is the size distribution data. We can also find the same file name, but the end as the TXT file. So the PDF file and the TXT file are the raw data from the software. And here, in the analysis menu, some things we can change, as I said before. So the video is already captured, so the previous sensitivity and the shutter you cannot change. But like for the post-acquisition parameters, you can change it. And this one, the ZP and the Zeta potential class, is only used when you're using the Zeta potential measurement. So for the size, you don't have to look at this. And this one, for the PSD class, this means the linear value of the size. The linear value of the size steps here. So the equipment recommended data is 5, and the PSD class is dedicated. Recommended value is 64. So normally you don't have to change these 2 parameters. So and the minimum and the maximum is changed according to your particle size. Like for this is around 100 nanometers. So this one can be set like smaller for the maximum area. And then every time you finish changing the parameter, you can reanalyze the data. So the histogram will change here. And after the finishing the analyze, a new PDF file will be generated. So these curves looks more smooth when we decrease from 30 to 5. And for the size distribution, we have another function. We click the scatter plot, and the x-axis is track ID, is how many data is tracked, and this one is we can use the mouse to select one kind of size distribution area you need. So they will have different plots generated here. And this is no raw data can be saved, only save screen. And the scatter plot is only available when you do the size measurement. For zeta potential measurement, we cannot click the scatter point. So this is the end of the size distribution measurement. So with the same batch of the gold nanoparticle sample, we go back to the measurement menu, and we this time we want to show how to measure the zeta potential of your sample. So for every zeta potential measurement, we suggest like you update the conductivity of your solution if you use any kind of buffer or salts. So check the conductivity here, and then also make sure these two are clicked, and the data setting requirement is the same. Make sure these two are green, and then run video acquisition. Also rename your sample and select your folder you need. And for this one, this is the gold size SOP we previously used. Now we click back to zeta potential, and for zeta potential, the recommendation test positions is two position. It means the SL1 and SL2 in the previously here. SL1 and SL2, the stationary layers. And if you are using the high conductivity solution, we suggest use the pulse mode. If it's low conductivity, as we used here, we suggest use the continuous electric field, and also 2 cycles. And we suggest use the high frame here. The moderate means 30 frames per video, and the high means 60 frames per measurement. And now this is the data setting, and then we save current, save the SOP. Press enter. So the green one means this time the zeta potential measurement for the golden nanoparticles is saved as an SOP. So you can reload the SOP next time for the measurement. Now we click OK. So when the zeta potential measurement finished, the software also automatically changed to the analysis mode, and this will generate the zeta potential histogram profile. And you will get PDF and TXT raw data. this is the end of the zeta potential measurement. So after you finish your experiment, go back to the pump and the temperature. Use pump 1 to remove all your solutions in the cell. So the pump will stop after 2 or 3 minutes, and then prepare some clean water to inject from the outside. So after pump cleaning, we inject 5 clean clear water from the outside. When finishing the experiment, the criteria is like you have to make sure the whole screen observed by the microscope, there is no obvious particles inside the solution. So if there is still some scatterings, keep inject the clean water. So make sure the screen as much as clean. The whole screen is in black. Then the next step is like inject 5, as much as more dry air to make sure all the liquid in the cell is removed. And you have to make sure there will be bubbles generated to the waste bottle to make sure the cell is dry. So we also use the syringe with just the air. Inject here. Since the equipment is very easily polluted by each experiment, so then we turn off the software. Before we leave, we have to re-click on the software. We have to check the cell is clean to make sure the next users can directly use the equipment. So we repeat the opening process. We have to make sure the cell quality result is still very good. So these two green. And we pump some water inside. So until the finish of the water filled in, you have to make sure this process, the cell quality is still very good. Then this is the end of the experiment. in these situations, if when you reopen the software, the cell quality is not good, like this is normally good or not good in the yellow color, the things you have to do is use the dry water to clean the cell, and also sometimes you have to disassemble the cell to cleaning the observation cell inside. Use the clean glass bottle and the screw, and also some so if the cell quality is not good, it's not in green, it's not good, you have to use the equipment we prepared here, the soft brush and the screw, and also the clean glass bottle to disassemble the cell here, and to make sure you clean the use some I think acetone to clean the cell, and then reassemble the cell here, and repeat this process again. So before you leave the equipment, you have to make sure the cell quality is very good. If the thing is not solved, you have to contact the technician immediately, and also remark on the logbook. So here the cell quality is still very good, and the chamber is filled with water again, and we do not continue the process, we just turn. Since, as I mentioned, the water from the pump, from the distiller, the water from the pump is not clean. You can still see the scattering. So we repeat the previous steps. We use the pure water filtered by the 200 nanometers filter. To remove that. Then we inject the air again, and this is the finish of the experiment. So a double check of the cleaning, the final cleaning process is needed. And now we turn off the software and make sure the cell is already dried with the air, fresh air. And then we turn off the equipment here. So the light here is turned off. Then you use the disk. You use your own disk to copy your data. So this is the end of the Zetaview measurement. Thank you for watching.